Okay guys, so welcome back to today mathematics class for this upcoming WAEC and JAMB examination. So we shall be diving into the this continuation of our previous class. We stop at chain and we stop at chain rules. Okay, now we're discussing about product and quotient rules. So let's dive into this. So okay guys, in the previous class I explained this some on different rules and chain rules, and here we are in the product rules. So let's dive into the product rules. So guys, in case you are just joining us for the first time or watching my video for the first time, do as to subscribe, like, or just turn on your button in case what you have been benefited like this, that may be the first one on fire. And also please take 1 minute of time to share this video with your friends along the social media or the friend around you so they can benefit from this video. God bless you guys as you take 1 minute of time to share this video with a friend. And don't forget to like, okay? And don't forget to like this video. I wish you more wisdom, knowledge, understanding, and success in this incoming examination. So, if you are joined for the group, you should know that you should have your pen and your book with you. So then write down your lesson notes. Listen and write your lesson notes. So let's dive to it. We have the first question of this. We have two parts here. We have the products and we have the quotient root. So what it does mean by product rules under differentiation? Okay, it has a general expression. Okay, for example, for this product rules, when you give an expression, they say y, okay, is equal to u multiplied by v. Okay, this is the example of product rule. They will have two terms together that will multiply together. Again, now they have two terms together that multiply together. So those two terms they multiply together, it is called that kind of try to differentiate it. It means that it is product rule. If you look at it, this was v. Okay, this one is u. Okay. UV means that they are multiplied together, and a product it means what? Multiplication. Okay, and the quotient is mean division. That is also different between the two. I get now when you are expressing product rules and we have the question like this, that is the question that look like this because the two of it, u and v, they are multiplied together. That is means of a product. Now when you are differentiating this one now, the answer if you find the s of this problem, it will be equal to differentiate it now with respect to s, it will be equal to. So what you just have to do here, if I differentiate this given question to differentiate this question to differentiate with respect to s, what you just have to do here, you leave what this v, the second time you leave it constant, that is v. Okay, and you differentiate this u, okay, with respect to s, that will be equal to v multiply what the u, the u the s, plus the second one you leave this one u constant, so u it will be equal to, that is the v, okay, with respect to the s. So when I give you this question, you first of all leave the second v constant and differentiate this u with respect to s, plus you leave for this u constant and differentiate this one v and differentiate this v with respect to s. So that is expression of product. That's expression of product rule. I get now. So that is the expression of the product rules. So in a very simple way, I say that you leave the second one, that is for the first, either you leave this one constant and differentiate this one, but just know that for the first differentiate will leave one of it constant and differentiate the second one. If you're leaving this one constant, okay, if you're leaving this one constant, you have to differentiate. If you're leaving u constant, you differentiate this y v with respect to s, and if you leave this one constant, you differentiate what u with respect to s. That is all about what product rules. When I give you the question under product rule, that is how you apply it. Now, so let's dive into the quotient rule. So let's dive into the quotient rule. For example, let me give you the expression of quotient rule. So let me to create a space. So in quotient rules, when you are given an example, when I say y is equal to u over v, so quotient, I said quotient is a division, y is equal to u over v. What you just have to do here, this is quite very simple. Many students are finding difficult to solve a question on a this, and it is very, very simple. Now, what you just have to do here, you you list our v constants. V constant and differentiate to this u with respect to s, so it means that v, okay, the u, the s, minus differentiation, it means what? Minus. Quotient is giving minus. Minus, you will not leave for u constant and differentiate this v respect to s. That is the v, the what? S divided by v square, the denominator square, divided by what? V square. That is all about what? A quotient rule. Let me repeat again. First of all, you leave this v constant and differentiate this u respect to s, minus you leave this u constant and differentiate v respect to s. That is what I have here, and everything is divided by v square. Anything we have in the numerator to be what? Square. That is all about the expression of the quotient rule. So let's dive to the example for better understanding and how you can apply this expression to solve problem in under differentiation. So let's see the example that I have here. It has very listing because this example is quite this particular topic in differentiation is little very confusing. So if you are not smart, you made a mistake when you are solving it. So let's dive to it. You have to question the questions that differentiate with respect to s. And the first one, you have 2s minus 1 is power of 3. You have s. Here you have s. Open bracket. We have s squared minus 1. Everything is power 2. And you have the second one, s squared. Open bracket. S squared minus 4 is power of what? Of 2. Close divided by 2s is power of 2. 2s is power of 2 plus 1. Everything is power of what? Of 3. Now let's dive into the solution of it. So let me solve we have solution. Now the first question here is some the same thing I explained here is called to what? The way I explained this, that is what? That is product rule. I said that this u is v is called to vu is the same thing as what? This one is just represented as v. Okay, y is called, this one is just represented as v, and this one just represented as what? As u. As simple as that. I get now. So let's just replace this the way it was. So if we say that our y, okay, our y is equal to, that is a 2s minus y. Sorry, this place I write it. What could happen? 2s minus y, okay. Everything is raised to the power of 3, okay, and also it will also multiply by open bracket. That is what? S is power of 3, S is power of 2, okay. This power of 2 minus 1, close bracket. Everything is power of 2. So let's say that this one represents u, and let's say this one represents what? As v. So let's say this one represents as u. Let's type like this, represent as u, and this one represents this part represent as v. So it means that our y now is equal to that u v. So it means that they multiply together, and this is under our product rule. Now let's apply the expression of product rule to solve this problem. Now to apply it now, it means that to find the y, the s of this problem, you must obey the rules, okay, the general form of the product rule. The first thing here, first of all, differentiate, because this one is in part v, u, and this one is in part v. So to make it easy to express, okay, let me write the expression out. We need to find our this y to respect to u. Just get you have the y, okay, the s, okay, it will be equal to, you will leave for this v constant, that is v constant, okay, and differentiate this to u respect to s, that is the u, okay, and the s, plus, and you leave for this u constant now, u constant, and differentiate v respect to s, okay. That is the solution of this problem. Now when you leave our v constant, now let's differentiate this u, okay, this with respect to s, and we say our u is equal to this. Since we say the u, okay, u is equal to we say u is equal to what? 2s minus 1, okay, and everything is raised power of what? Of 3, because this one is raised power of 3 here, okay. Let me put that one is power of 3 here, right? One is power of what? Of 2 here, according to the expression we have here. Now let's differentiate this one with respect to what? To s. So if you look at this one, and this is the quotient rule we discussed yesterday. This is quotient rule. I mean chain rules rather. This is chain rules. Okay, so you have to represent this one with a certain things. Okay, let's represent this one with a certain letter. So let's say this one is equal to t. Let's say it's equal to t. T is equal to, that is 2 what, s plus minus 1. Okay, let's say it's equal to a minus 1. Then our u now becomes, so let me try to write it down. So our u now becomes, u is equal to, that is of t raised to the power of what, of 3. Now let's differentiate this t with respect to s, and let's differentiate this u with respect to t. Now you get our answer as the u ds. Because remember, the chain rules I explained in the previous class, and if you're just joining us today and you haven't watched your previous class based on that chain rules, I will leave the link in the comment section or in the description of this video, so you can go to it and check it out. I'll go to the comment section and request for the link, so I will direct you how you can get access to the class. Now let's dive to it. Okay, let's differentiate this u respect to t, and let's differentiate this t respect to let's differentiate this t respect to what, to s. Now to get your du ds of this question, you get your du ds, okay, to be equal to, so you have to differentiate. Okay, you differentiate this t respect u respect to t to be equal to, that is the t, okay, the u respect to t multiplied by, okay, the second one, you differentiate this one, this t respect to s, that be equal to the t respect to what, the s. So this one cancel this, we have the u dt that we're looking for. Now that be equal to, so let's differentiate this one respect to t. So if you differentiate with respect to t, it will be equal to, so let me say that, write it here. Okay, that is the t, okay, I have the u rather, the t. So the u dt, right, this one becomes there, and so that one for this, that be equal to 3, okay, 3 t raised power of what, right, so that one for this 3, that be equal to what, 2. Now in the previous class I explained how I arrived this. Means that the base here, I mean the index here multiplied by this t, and we have to subtract 1 for this t. That's the general expression of differentiation. That's why I did this 3 multiplied by this 3, and we subtract 1 for the power here. That is why I have 2. So the u dt is equal to 3t squared. Now let's differentiate this t, okay, let's differentiate this t, that is the t, okay, the t respect to what, to s. So differentiate this t respect to s. So this is a constant. Constant is always equal to 0. Okay, this is a constant, is always equal to 0. So when you differentiate this one, here is 1 is raised power of 1 here. S is raised power of 1 here. Okay, 1 times 2, that's equal to what? That is 2. Okay, and when you subtract 1 from 1 here, that is equal to what? 0. And any t raised power of 0 is equal to what? That is 1. So 1 times this 2, we get what, as 2. So it means that the t respect to s is equal to this. I've explained this question, I break it down in the previous class, so under the chain rules. So if you haven't missed it, in case you don't understand this part, you can check this video. I'll break it down step by step, because I don't want this length of this video to be too much like that. That is why I've tried to explain it in a short form and a fast form, in case you meet this question in this upcoming JAMB examination, so you can be able to fast and how you can get it since you have understand the background. Let me repeat again. So when you differentiate this one, this is a constant, okay, so this constant is always tend to 0. So let's do it, the one that has s, okay, and this one, this s means that it's raised power 1 here. So 1 times 2, we have 2. Okay, now they have s here. Let's this s now. So you know, subtract 1 from this, or 1 from this one there, that give us 0. So it means that s is power of 0, and anything is power of 0 is equal to 1. Okay, and 1 times 2 is still have 2. So it means that the t, okay, the t ds is equal to this, and also the u dt is equal to this. So let's apply to the to the chain rules now, and then we get our the u dt, okay, the u ds. So let me write let me create another space. So in this place now, so let's input in this way. We have our du, okay, the u ds now is equal to, so the u dt, okay, the u dt, our du dt, we get our du dt. Our du dt is equal to 3 what? That is a 3 t raised power of 3, okay, and our the t ds is multiplied by, okay, that is 2. Now if you still remember, this t, I said t represents as this, right? So it means that what this one now becomes, that is what the u, okay, the s, okay, the ds is equal to that is 3, 2 times 3, that is 6. So we have 6, okay, we have 6, and this place, okay, 6 1 raised to the power of 2, rather, try 2, here is 2. So because we have a 3 2 raised to the power of 2 here, that is 2. Now we have 3 times 2, that is 6, and open bracket, and our t raised to the power of 2, that is our t is equal to, that is a 2 or 2s minus 1, everything is power of 2. So it means that du ds is equal to this. So we have get our du ds. So let's get our dv ds. Now we still solve this part, so let's remain this part dv ds. Now to get your dv ds, so this is our v. I said our v represented as this, so let's say the v, okay, v is represented as what? As s squared minus 1, and everything is raised to the power of what? Of 2. That is our v represent. Now let's differentiate this on respect to s now. Okay, we want to differentiate dv ds, so we have our dv, okay, dv or ds is equal to, so that the same thing apply as the quotient rule. So you can represent this one as a letter. Okay, let's also represent as what? As letter t. Okay, so to expand this one in quotient rule, you have to differentiate the u, okay, this v rather, the v respect to t, okay, multiply by, and also represent the t, okay, respect to s. Now let's call this one as t. So let's say t is equal to, now is s raised to the power of 2, s raised to the power of 2 minus 1. Okay, that is the value of t. Now our v now becomes, that is what? T raised to the power of 2. Now you say our t is equal to s squared minus 1, and our v is equal to t squared. Now let's differentiate dv dt. Okay, and then we differentiate dt ds. So let's first differentiate this t, this v respect to t. So we'll differentiate this one respect to t. Now to get our dt, okay, the v dt now it will be equal to, we have to differentiate this one respect to t. So this power here, we multiply the base here, that is 2, okay, I get now. So t, and we subtract 1 for this 2, that is t raised to the power of 1, so that is 2t. So it means that the v dt is equal to 2t. Now let's differentiate this one, okay, let's differentiate this one respect to that is dt ds. Then increase more space. So the TDS, so the TDS is to be equal to, so when you do this one respect to what? I respect to s, this is a constant. The constant will be equal to 0. Okay, and now let's do with the one that has s. So this power here multiplied by the base, that is what? 2. Okay, and we should solve out for this power here, that is 1. That is s is power, s is power of 1, that is 2s. I get now. So let's put it into what we have here, and then we find out the vds. Let's put it there. I think there's no enough, sorry, there's no enough space. Okay, let me come and solve it here. Let me create a space here. So it said our the TDS is equal to this, and our the VDT is equal to this. Now let's put it to general expression here. So to get your dv, okay, to get your dv, okay, the okay, ds, it will be equal to. So we have our dt. There's a dv, I mean the vdt, and the vdt is equal to 2s. That's good, 2 rather. We have 2 or 2t, okay, multiply by, and our dt, ds is equal to 2s. So here we have our 2 or 2s. Now, if you still remember, t is equal to this, t is equal to s squared minus 1. So if you put it here, so it means that our dv, okay, ds is equal to, that is 2 times 2. That's equal to what? 2 times 2s. That's equal to 4. Equal to 4s. Here we have 4s, and let's put the bracket our t now. Our t is equal to s squared. We have s squared minus 1. So we close brackets. So that simply means that our dv ds is equal to 4s open bracket s squared minus 1. That's our dv ds. Now Let's come back to this. We have solved this one, the VDS, and I have solved this one, the UDS. Our UDS, what do we get? We get as our UDS is equal to 6 open bracket 2s minus 1 square, and we get our the VDS is equal to our s square minus 4s open bracket s square minus 1. So let's put it into the general expression now, and then we get our solution. So we have our like this. I think this we can contain it. So let me try to create a space. Let me start from the square. This topic, if you are not listening very well, you made a mistake. So let me start from this way up. You can see it from that place. Okay, I want to. Okay, where's our the okay, I'll see it. So let's dive today. Let's put it into the general expression we have here. So here we have the y ds. So to get our the y ds, we have the y. Okay. The s is be equal to, so in this place we have to look what v constant, and what's our v? Our v represents as what? This is our u, and this is our v. Okay, that is v is equal to what? S square minus 1, everything is power of 2. So let's put it there. That is what, open brackets. Okay, that is s square minus 1, everything is power of 2. Okay, multiply by, so let me open bracket for that multiplication. Let me use the bracket as multiplication. We have our du ds, and what they get as our du ds? Our du ds we get is total as this. That is what is equal to 6. Okay, 6 open bracket, that's equal to 2s minus 1. Okay, everything close bracket is power of 2. I get now. So we close brackets. Now we have done with this part. So let's go to this part. That is plus. This way cannot contain it, and we need this one. Okay, let me try to write it down here. That's plus. Okay. So here I have to use leave for u constants. This is our u. Okay, that's equal to bracket. That is our 2s minus 1. Everything with power of 3. Okay, open bracket again. And multiply by what? Dv ds. And dv ds, that is what we get here at 4s what? That is 4s and open bracket, that is s square minus 1 close bracket. I get now. So we have expressed it now. So what you just have to do here now, okay, to get your final answer, okay, either you stop at this way where this one still has solution. What you just have to do here, if you look at it, if you find the factor of it, this part, in this part and this part, what is the thing that is common here? We have s raised to power 2 minus 1, you have s raised to power 2 minus 1 here, so it means they are common, and the lowest one is s raised to power 2 minus 1. And if you look at this one, that is 2s minus 2, 2s minus 1 is also common to this place. Why this one is in 2 form, why this one is in 3 parts. So this one is part of 3, why this one is part of what? Of 2. Let me explain like that. Now when you pick the common factor outside now, you can follow the first, because s, okay, you have s square, okay, you have s square minus 1 is common to both sides. Why this space is half s square, that is raised power of 2, raised power of 1. So we write the lowest one, which is this one out, raised power of 1. And second one also, we have this one 2s minus 1 is raised power of 2 here, while in this part it is power of 3. So you have to write the lowest one, that is 2s is power of 2 here. That is 2 or 2s minus 1 it is power of 2. So that open the big brackets. Now when we use this one to divide by this part, what remains is this one is power of 2. So it means that this one remains what is 1 here, 1 times 6n. And in this place, if you use this out s square minus 1 divided by this s square is 1 square, so it means that we miss 1 here. Why this one remains 1 here? Okay, this one becomes 1 because 2s minus 1 square divided by 2s minus 1 square, everything we cancel, so we make 6. So this one means what? 6. Okay, open brackets. And in this place also, when you use this one, s square minus 1, okay, divided by s square minus 1 square, this one means what? S square minus 1. So that is why this one, because s6 minus 1, 6s square minus 1. So that will be the answer for this part. Now let's go for the second part. We have plus, okay. When you use this one to divide by the s square minus 1, so it means that s square minus 1, this one will cancel. So it makes what? 4s, okay. So we have 4s and open bracket. So here is let's use this 2s minus 1 divided by 2s minus 1 square. This one is square. So 2s minus 1 raised power 3. It means it remain 2 of it to subtract for this one. So it remains 2s minus 1. So it means this one means we have 2s minus 1. Okay. So that is the solution to it. That is, so you can expand this one to get your final answer. You can expand it 6 times this and open the bracket, and also this times this to open your bracket, and still get your answer. Either you leave it like this or you should proceed more about this. So that is the solution today. Now this one take too long, right? That is how it's very interesting. Okay, so if you are not smart enough, you can do mistake when I'm solving this product too. So the next video, let's go to the example of the quotient tool I have for you. Okay, let's example of the quotient tool I have for you. So that is our question B. That's question B. So this is what we'll be treating in the next video. Okay, this is what we'll be treating in the next video. So let me give a class work if I go. Let me give you the classwork. Okay, because say this is the classwork. The first question is still under that. Okay, let me bring my pen out. So this is the classwork. Solve it. So the classwork, solve this classwork to be submitted. So if you're just joining our channel for the first time and wish to submit this classwork for correction, in case you don't understand it or you don't know how to solve it, okay, you can shout me up on WhatsApp. So you want to request for how to join my WhatsApp group, so where you can access to our class. So you can ask a question based on the video. So okay, let me give me the phone number to shout me up to submit your classwork. So let's go. We have 090 okay 61 okay 22 16 and 56. So that is the WhatsApp number. Don't call it, just message out on WhatsApp. So you can drop your solution for correction. So thank you. Let's move to the next class. So where we're talking about the quotient rules.